All right, the second half of lesson 9. So remember, we're investigating the question, what can affect the size of a population besides its resource and consumer population? So we're looking at those things outside of the jellies and the zooplankton and the turtles. So now that you've learned about competition and indirect effects, you're going to carry out those ideas on a mission in the sim. It doesn't work, does it?
I love to yes.
And that works? I don't think any of it works, but go ahead and try. Let me know. To prepare for your mission, you will find, huh? It really did? Oh, nice.
So smart.
You are smart, Jacob. You win the award for today. The SMART award. To prepare for your mission, you will find 2 populations that compete for the same resource in the sim. Then you will try to increase one population by changing the other. So here is a food web showing populations from the sim. Think about the question below. Which 2 populations in the sim compete for the same resource population? Let's look up at the board. Let's not worry about computers right now. What 2 populations compete for the same resource? These are all the populations from the sim. Which 2 eat the same thing? There's only one circle that has 2 arrows leading it. Jacob?
The furbill and the stingwing.
Good job. Both eat the what?
Eat the wee bug.
Right. So we could see from the food web that both the furbills and the stingwings eat the wee bugs. So this means that the furbills and the stingwings compete for the same resource. So this is very similar to our sardines, our zooplankton, and our jellies in those ecosystems in Africa. Now you're going to use what you've learned about furbills, stingwings, and wee bugs to complete a mission. Your mission is to try to increase one population by changing the other. So you're going to increase one of these in order to change the other one. As you work on your mission, you're going to use the 6 populations mode. Up to this point, we've used the one in the middle, so you're going to use this last one. Having more populations allows you to test the effects of changes to populations that are not directly connected. Remember, you can press the icon at the bottom left to view a food web for the sim ecosystem. Before you make your change, you're going to let the sim run for 40 time units. Last time we let it run for 20. We're going to let it run for 40. Then you'll make your change, press play, run the sim for another 100. So similar to what we've done in the past. When your test is done, you go to Analyze and use the range window to observe the population sizes after the change. Finally, you'll explain what happened. All right, so let's now see if our computers are working. We're going to go to Google Classroom and open up the number 2. Okay, so this is our document, competition in the sim. Some populations use the same resource, such as eat the same resource population or food. In this sim mission, you're going to focus on 2 populations that compete for the same resource and try to increase one population by changing the other. The food web from the sim is below for reference. So here's our food web once again. We've already talked about how the furbills and the stingwings both rely on those wee bugs. So planning a sim mission. Make a change to the furbills. Hope I should leave that up. That will cause the stingwing population to increase. So what could we do to make the stingwings go up? Do we want to increase or decrease the furbill population? They both eat wee bugs.
Decrease.
Huh?
Decrease the furbill population.
All right, so if we decrease the furbill population, so if you have your doc, you want to highlight that, or if you're jotting down answers, jot down decrease. The furbill population will cause the stingwing population to increase. Just like when the sardines decreased, the jellies went up. Now complete the mission in the sim. Make a change to the furbills that will cause the stingwing population to increase. There is a video there for you to watch if you're finishing this up at home. So I'm going to go ahead and launch my sim, and then it says to go to the 6 population mode. Okay. Let the sim run for 40 time units, and then I'm going to make the change to the fur bills that we selected on the previous page, which was to decrease the fur bills. So this is going kind of slow, so I'm going to speed it up a little bit. Pause it at 43, that's fine. And I'm decreasing my fur bills. I don't want to have 0. I'm going to leave it at like 5 and lock it. Press play and let the sim run for another 100 time units. So now I got to pause it at 143.
Good morning, pardon the interruption. The Wi-Fi issues have been resolved. Thank you.
All right, guys, go ahead and give it a try. Let's hope. You may want to just restart your computers after everything we did.
What?
I'm sorry?
How much do we increase the fur bill?
I put my fur bills down to 5. I'll just share my data with you guys. Unless you want to do it, you can. So then we're going to go to Analyze and use the range window to observe the population sizes after the change, answer the questions below and on the next page.
Sure.
Good. So after the change, we want to know what happened to the wee bugs, and we want to know what happened to the stingwings. We are looking at overall population numbers. We're not looking at births and deaths like we did in the past. So my population, wee bugs, when you look at this over here, it gives you your population, and then it gives you your change, how much the population changed throughout time. And so my wee bug population went down by 7. And my stingwing population went up by 6. That's what my data says. Plus 6 and minus 7. So if I go back to my document, my wee bugs, they probably shouldn't have decreased though. Should they have? My wee bugs should have went up. Let's go back here. Let's do it this way. They did go up. All right. So here's, remember the teardrop. That's where your change is. So I put my range window, and the directions did say to use the range window. I apologize. I take my range window before my change, and for wee bugs, I have 98. And when I go to the end after my change, I have 225 wee bugs. So what did my wee bugs do? They went up. They increased. So on your document, you want to highlight increased. And then if I look at my stingwings before the change, I had 13. And after the change, I had 15. So not much of a change, but did they go up? They did. So I want to say that my stingwings also increased. So now you want to explain why the change you made to the, explain why the change you made caused the stingwing population to change. Use energy storage molecules in your answer to explain. So you want to now say, why did the stingwing population change? Think back to our food web, right? We changed our fur bills. We made that go down. Why would that cause the stingwings to go up? Go ahead and type your answer. And then answer the final question, and then you can turn it in. So we found that both furbills and stingwings eat wee bugs. If there are fewer furbills, they will eat less of the wee bugs. That will leave more wee bugs for the stingwings. With more energy storage molecules from a larger wee bug population, the stingwing population can reproduce more. This leads to more births than deaths and an increase in the stingwing population. Your answer should have been very similar to that, okay? Especially with the energy storage molecules. So the article and the sim both gave us evidence for our 10th key concept, and that is that two populations can compete for the same resource population. A change to one of these populations affects the size of the other. We learned that that is an indirect effect. So we can now answer the question we've been investigating. What can affect the size of a population besides its resource or consumer populations? Populations other than the resource or consumer population that are not directly connected, so they don't have that arrow going to one another, on the food web can affect the size of a population. We call these indirect effects. When two populations compete for the same resource population, a change to one affects the size of the resource population. This, in turn, affects the size of the other consumer population. Competition caused the jelly population to increase in North Bangula, and it's possible that this is what is happening in Glacier Sea. However, we will still need more evidence about why the moon jellies increased in Glacier Sea, and in the next lesson, you'll get more evidence and consider other kinds of indirect effects. So we have one more big main idea to get through, and then we'll have all of our information, and you'll be able to make your final arguments as to why the moon jellies in Glacier Sea increased. Questions? All right, so